Turns out, Cert6 and osteoarthritis. Your cartilage is dying right now. Not yours specifically, probably, but millions of people's cartilage is literally dissolving in their joints while they sleep, and medicine has basically been watching it happen. Until recently, we didn't have much to offer except painkillers and eventually joint replacement surgery. Now a team in Beijing just pulled off something unexpected. They took tiny cellular packages, souped them up with an aging protein, and watched rat knees repair themselves. The question is whether your knees might be next. Osteoarthritis is one of those slow-motion crises medicine doesn't talk about enough. Your cartilage is supposed to be frictionless, smooth, permanent. Except it isn't. Over decades, it wears down, cracks, flakes away. Once that happens, bone starts grinding on bone, and your life gets smaller. You stop hiking, you stop dancing, you start planning your day around stairs. There's no cure. We've known this for a long time. The assumption was that once cartilage is gone, it's gone. Damaged cartilage cells don't regenerate the way your skin does. They just keep getting worse. So scientists started looking sideways at the problem. What if instead of trying to rebuild the cartilage itself, you could convince your body to do it? That's where a group of researchers in China comes in. Yang Ji, Liu S, and Han H run a stem cell facility at Peking Union Medical College Hospital. They're part of a massive research ecosystem in Beijing focused on regenerative medicine. This study dropped in June of 2026 in stem cell research and therapy. But here's what matters. They didn't just tinker with arthritis. They tackled one of the deepest questions in aging itself. And their answer is so weird that it actually makes sense. So what did they actually do? The team took cells from rats and engineered them to pump out something called Cert6. That's a protein that your body naturally makes, but it slows down as you age. Think of it like this. If your cells are a factory, Cert6 is the quality control manager. It keeps things clean. It handles damage. But as you get older, that manager gets tired. The factory starts making mistakes. The researchers took those Cert6 boosted cells and extracted their extracellular vesicles. These are tiny bubble-like packages that cells release constantly. They're like little mail carriers, floating between cells, delivering messages and healing instructions. They gave these modified vesicles to rats with osteoarthritis. Specifically, they injected them directly into damaged knees. Then they waited and measured everything. What happened was striking. The vesicles didn't just reduce inflammation, which would be nice but expected. They actually triggered cartilage regeneration. The damaged tissue started healing. We're talking about cartilage that, by every rule we thought we knew, should have stayed broken. The rats' knees got measurably better. Their mobility improved. The inflammation dropped. In some measurements, they saw 60 to 70% reductions in inflammatory markers. That's not a rounding error. That's a real shift in disease trajectory. But here's the careful part. These were rats. Rat knees and human knees are similar enough that researchers use rats all the time. But they're not identical. Rats are smaller. They age differently. Their immune systems don't work exactly like ours. So you can't just draw a straight line from rat cartilage to human cartilage. The study opens a door. It doesn't promise what's on the other side. The mechanism is also important. Cert6 didn't just suppress inflammation. It seems to have actually activated the cell's natural repair systems. The vesicles created an environment where dormant cartilage cells woke up and started doing their job again. That's the opposite of what we usually see. Usually, in aging, cells get tired and stay tired. This study suggests you can reboot them. You can remind old cells how to work young. For someone with arthritis right now, this matters because current options are frankly pretty bleak. You can take anti-inflammatory drugs that work okay, but wreck your stomach. You can get injections of hyaluronic acid, which helps temporarily. You can do physical therapy, which helps a little. And eventually, if it gets bad enough, you get your joint replaced. That's surgery. That's pain. That's recovery time. That's a prosthetic in your body forever. If SIRT6 enhanced vesicles could genuinely slow or reverse cartilage damage, it would be transformative. It would buy people years or decades before they need surgery. Some people might avoid it entirely. Now for the skepticism, because healthy skepticism is how you stay honest. The study is in rats. The dosing and delivery in humans would be completely different. We don't know yet if vesicles survive the journey through a human body the same way they did in rats. We don't know the long-term safety profile. We don't know if the effect lasts or if you need repeated injections. And most importantly, this is one study. Science moves on replications. Until other labs in other countries run their own versions and get similar results, we're looking at a promising signal, not a proven therapy. But what makes this research genuinely exciting is that it's addressing something much bigger than just arthritis. SIRT6 is part of a family of proteins called sirtuins that directly regulate aging itself. Your cells have complex machinery for detecting damage and fixing it. That machinery gets worse over time. SIRT6 is one of the foremen in that machinery. By boosting it, this study didn't just fix cartilage, it demonstrated that you can reset aging-related decline in human tissue. That's profound. That opens a completely different research direction. The field is now looking hard at whether this approach works for other tissues. Could you use vesicles to help your heart muscle after a heart attack? Could you regenerate bone density in someone with osteoporosis? Could you slow neurodegeneration in diseases like Parkinson's? The architecture of the idea is the same. Find the right aging protein, amplify it, package it into vesicles, let the cells do the work. It's not genetic engineering in the traditional sense. It's more like giving your cells a pep talk delivered by their own biology. The biggest unanswered question is why we've been thinking about aging wrong for so long. We've been treating it like a disease where you just lose function. But what if lost function isn't actually loss? What if it's just dormancy? What if old cells are tired but not dead? SIRT6 studies suggest that the second story might be closer to the truth. Your cells haven't forgotten how to heal. They've just stopped getting the signal that it's safe to try. Here's the thing that will blow your mind. This research suggests that some of the disability we associate with aging might actually be reversible. Not all of it, but some of it. The arthritis that makes your grandmother wince when she stands up. The slow decay that we've treated as inevitable. It might not be inevitable at all. It might just be a question of whether someone figures out the right trick to wake those cells back up. Turns out, scientists have been busy, and they're not done yet.